vast data. We've had you on the field day platform a few times now. It's been a rocket ship. John, Neeloy, talk to me about the valuation of the company. Let's get I'm going to let you guys kind of, get your victory lap in. Tell me about the past few months.
Start easy. Yeah, we've been experiencing high amounts of growth. We just closed our round last quarter, putting us at $9.1 billion in valuation. And a lot of that, thank you. Yeah. Can't take sole responsibility for that.
I think Ray got some stock.
Yeah, good.
Yeah.
A lot of that's just purely attributed to the fact that our business has been tracking in the same way, right? So we've been seeing nearly doubled to 3x growth. We've closed in the first 4 years of selling over $1 billion in software sales alone. This fiscal year we just closed. I don't think we have the final numbers yet, but it's going to add a big chunk to that top line number for us. So we're pretty excited.
So with that, and field day delegates, feel free to jump in whenever. But I'll do one last victory lap, then the CTO advisor is going to come out. 6% of the data center market, flash market. That's it may sound insignificant, but a single independent software data platform company getting that much of the data center market is a big deal. Companies are starting to notice you, but we're at AI Field Day.
Yeah.
And as the delegates will tell you, these folks are sharp when it comes to, I'll tell you, these folks are sharp when it comes to AI. And you're a storage company. Explain, why are you at AI Field Day?
So I think a lot of people may not know this. I think in the last 4 years now, we're tracking to about 10 exabytes of data deployed into the market globally. We have customers almost in every major country around the world now. But out of that 10 exabytes, about 60% of our business today is being used for AI and HPC workloads. Right? So many people think about us as a enterprise storage solution, which we'll talk about that more in a second. But the reality is, from a workload perspective, it's been in our DNA even before AI was, a trending topic in the industry. So yeah, we're very fortunate to have great, I call them partners, right? Design partners that are working with us. We're on the bleeding edge. I mean, it's still early innings today on the AI front, but we've learned a lot in the last 2 years working with very, very, very large customers. A lot of big AI service providers that kind of come on the scene. Companies like CoreWeave, Lambda Labs, Core42, Genesis Cloud. All these companies are now building huge AI clouds. We have the fortune of building them with them along the way. So that's why we're here partly.
So, from a anecdotal perspective, I was at Supercompute 23. The vast booth was
booming.
It was booming. It was slammed.
Yeah.
So I get the HPC story, but what's unique about the vast platform that makes it suitable for AI workloads?
Yeah, I think the funny thing is, I don't know if you saw, but last summer we also kind of unfolded a lot of what Redden, our founder, his vision for the company when he started this back in 2015. I actually saw his original investor deck. I met him in a coffee shop in San Jose, actually, here in 2016, and he had just explained this crazy idea of building this new data center scale computer, right? That was effectively a thinking machine, and he had all these ideas, grandiose ideas, and he also had a roadmap, right? Like, it's not something you can build. You can't build Rome in a day, and he had a plan in his mind of how we're going to get there. And what I think the market has seen thus far has been our first act. Our first act has been storage. Right, we built a storage system that is extremely scalable, highly performant, extremely economical, right? And that's kind of helped us propel and build our foundation of success as a company. But that's not where Redden's vision all along was. That wasn't the end, right? That was kind of like the beginning, the phase one, the act one of the company. And since then, if you actually go back in the summertime, we had this big Build Beyond event where we're starting to be a little bit more transparent about our strategy. We're a pretty transparent company as a whole, and we started to introduce new capabilities that go beyond just what you would classically think of as storage, right? So when you think about, I'm sure we'll talk about this in a little bit more detail, but to me, AI is not like a classic enterprise application where you just need to be able to read and write data to disk. There's actually other parts of a pipeline that have a lot of data requirements and data needs that have to be addressed if you want to be truly successful in AI. And we hear this all the time from our customers today in the market. It's more than just speeds and feeds, bits and bytes onto disk.
So we've heard about these practical challenges throughout AI Field Day. How do we get the models that we want from a Hugging Face down into our data center, into our cloud? How do we apply RAG to the data sets? How do we get our data into a repository that we can use? How does VAST help with that overall pipeline and ensuring that whether it's my private data, data with partners, et cetera, gets through kind of this AI pipeline?
Yeah. So one of the innovations that John talked about, right? So we started off as a storage platform, and we built a set of capabilities on top of that. And one of those capabilities is a unique thing called a data space. Up until very recently, the notion or the concept amongst, even in big data and analytics has been, I'm going to move my data to a certain location, and then I'm going to try to extract value from it. I'm going to move it to a SaaS provider, I'm going to move it to a hyperscaler, and then I'm going to try to extract value from it. The problem is, just like you said, when it comes to AI and the massive amount of data that you're dealing with, that becomes very challenging. So one of the aspects of our vision is this concept of a global namespace that is write consistent. So you can go ahead and generally everything you're doing with AI, you're doing some sort of a data preparation step. And in that preparation step, you're looking at that raw data and you're doing some sanitization to it. You're doing a little bit of cleanup before you'll use it somewhere else. What the vast data space does is it gives you a landing zone for that prepared data, ideally as early in the data prep step as you're willing to do it. And once that information is on the VAST platform, it is now available everywhere. So you can have distributed inference, right? Model serving across a bunch of different edge data centers, hyperscaler, on-premise, doesn't matter. And all of those locations can work off of the same RAG data set, right? They're retrieving from a common data set. All of the prompts and responses that are being captured at those sites are being deposited into a common location, which VAST has a structured table capability called the VAST database. So those are some of the areas where we really help customers approach the AI pipeline and AI workload in a different way than they have approached traditional big data workloads, right? Where it was move first and then try to extract.
Are you talking about like a vector database or just a global file space kind of thing?
Exactly, right? So it doesn't, we don't try to, so our platform is multi-protocol, right? And one of the unique aspects of our platform is we don't do any sort of translation, right? So it's not like we store it as a file object or file entity and then present that as an object, right? So whether you're storing a file, an object, a row in a table, those all get stored as elements on our platform, vector database included, right? So regardless of how you're consuming it, the global namespace is at the element layer. So every instance of the VAST cluster is aware of the same elements, whether those elements physically reside in that particular instance of the cluster or not.
So the story resonates with me. I have a pharma background, and we would have genetic sequencers out in the field.
You got it.
Whether we're talking about in the clinic, in a research facility, we'd have facilities in Germany, in New Jersey, in the West Coast. We're collecting all of this data, all of these elements, and the data scientists across these regions needed to access this data in a uniform fashion. And we could never find a solution for this. Like this was a serious problem. So we'd have this isolated sets of data. We'd have an isolated workflow. Each data scientist was basically, or actually in this case, each scientist trying to cure diseases. In this case, Alzheimer's. They could not collaborate effectively or with speed across the data set. So this sounds like a solution that would solve
It
that problem.
absolutely does. And yeah, we talked to it. Life sciences is a very successful vertical for us. And that is exactly one of the use cases, is having, like you said, right, without having to pre-move, without having to pre-stage all of the data into certain central locations. And then, if somebody wants to analyze it, I got to move this whole data set over. Being able to be a lot more intelligent about when data movement occurs and making sure that data movement is occurring because of an actual workload need, not just because you're going to pre-stage the data, because there could be a workload need in the future. That's very, very critical to success here.
And some of the practical challenges that we ran into is that data has gravity.
Yep.
Like seriously,
Absolutely.
data has gravity, and moving and pre-staging data. We tried caching solutions. We could never get the hit rates up to where they needed to be.
Yep.
So obviously we went to the next phase, which was to move the compute closer to the data.
Yeah.
But we're in an era, quite frankly, that moving the compute is not that simple. Like I can't say, I have an NVIDIA system, a Dell system with 4 NVIDIA cards in every region. I just can't do that. Even if I could afford it, there's power requirements, et cetera, et cetera. So help talk to me about how VAST is helping solve this data gravity problem when it comes to compute services.
So one of the things that goes back to our architecture, right? So when VAST was created, we generally in the industry started to accept shared nothing architectures as the standard, right? Google had released the GFS paper in 2003. Everybody started to kind of, grab onto that notion. And so we generally accepted this shared nothing architecture. One of the things that Renan and the founding team did when they created VAST is they talked to a lot of customers. And what they heard from customers, just like you just said, was data movement was very, very painful. And not just data movement between regions, data movement amongst tiers.
Within the data center.
Right? Within the data center, within a product. Tiering made it so that the data you needed was in the lowest speed tier, right? And you had to wait for it to warm up. So we created this disaggregated shared everything architecture, right? So as we presented previously on field day, our architecture consists of a completely disaggregated logic and persistence layer. All the data lives at the persistence layer. All of the logic stores no state. None of the logic nodes talk to each other. So one of the things that was needed to make this architecture possible was a highly, highly scalable metadata layer, right? There's our metadata, there's no metadata lookup servers. And I recall that was one of the challenging things at field day that people were, how do you know where a block of data lives? Well, our metadata is self-describing. You don't have to go to a specific location. So we came up with this highly scalable metadata layer. And that metadata layer is the key to achieving the global namespace, because we can distribute that metadata far more rapidly than we can distribute the actual data. And then, using some intelligence around prefetch algorithms and things like that, where there is data movement, obviously, to your point, data has gravity, but the metadata layer and us understanding at a global scale the access patterns around the data lets us pre-stage data in a far more intelligent fashion than otherwise possible.
So non-data people can underestimate the value and importance of metadata when it comes to managing their data and preparing it for AI. Interesting that you pronounce your feature within vast database. There's kind of that comma there, that hesitation.
Yes, yes.
Talk to me about the capabilities when it comes to prepping data. It was, someone was talking about how they practically get ready for training in AI and inference, that they're spending, up to 2 weeks getting the data ready
Yeah,
before it's trained.
absolutely.
How does VAST help with that kind of prep
Yeah.
phase?
So VAST, one of the things that the database didn't come out of, Renan one day saying, hey, I wish I were to create, a database, or I want to be in that market, right? The database came around the problem of scanning large amounts of data, right? So once again, the accepted practice out there today is that your data gets stored in rather large files, right? Parquet files with some metadata around it, and that you read these files into memory of servers, Spark servers, other types of technologies, and you scan them for the information you're looking for. So when that problem statement was presented to VAST, what we realized is that since we store the data, we could in fact be a lot more intelligent about how that data is scanned or read, not needing to move it somewhere to understand what lives in it, but actually be able to push predicates down from a product like a Spark or a Trino, and be able to do that scanning work on the compute node itself, not have to move the data somewhere else, but within the VAST platform, the compute nodes, the logic nodes that we have, you could actually do that scanning on the logic nodes. So actually, we've now gotten to a point that at GTC we'll be demoing integration between Spark, Rapids, and VAST Database.
So to steal a silly vision AI example, hot dog, not hot dog. If I'm at the edge and I'm scanning in a bunch of hot dogs, not hot dogs, and I'm attaching this metadata to it, I can now understand from a data scientist perspective, from a platform group, do I even need to pull data from this site?
Right.
Should I even look
Exactly.
at it? So my good friend Howard Marks will remind me of saying the fastest data transfer is the data transfer you never have to do.
Yep,
Yeah.
absolutely.
I think the way to think about the database, just to put it into context, right, is we obviously, as a scale out NAS product, store a lot of unstructured data, right? The database is a way to assign structure to unstructured data, right? So we have a lot of different ways to do this. Your example, right? If you had an inferencing engine that determined it was a hot dog, you could actually tag custom metadata that said this is a hot dog. Rather than walking a file system, you can actually query that table and say, find me all the pictures of hot dogs, and we can give it to you lickety split, right? So that's an example. I think the other thing that, just to kind of put some context around the pipeline, I'm sure today and this week at AI Field Day, everyone's talking about latest and greatest processors and GPUs and flops and all of that stuff. But it's pretty commonly known in the industry that if you look at where the effort is, the man hours, I think the general rule is like 80% of the man hours actually goes into the effort before your training jobs actually kick off, right? So what does that mean? It means, how do you capture data? It means, how do you prepare the data? How do you wrangle all that data? Cleaning the data, right? Removing bias. All of that work typically happens not on your AI supercomputer, your NVIDIA GPU clusters, right? It's happening somewhere else. And those are big processes that tend to be fairly heavyweight. They're very inefficient. Like Neeloy said, a lot of it is still using antiquated, data processing frameworks where you have to read large amounts of files into, I apologize, large amounts of files into memory. The database also gives us the ability, because we're storing data at a very granular row by row level, we can now do very interesting integrations with a wide range of data preparation tools. So Neeloy mentioned like Apache Spark is a great example we'll be doing a demo of, but we've seen acceleration of ETL tools, query engines that now can tap into the vast database and provide, orders of magnitude of acceleration, reducing the amount of data preparation time that's necessary. That moves the needle, right? In terms of moving AI projects forward faster, we're focusing on kind of where can we squeeze out inefficiencies end to end.
So John and Neeloy, I really appreciate you two supporting Tech Field Day, coming through and willing to sit on the hot seat. Did a pretty good job. I gotta admit, I was really hoping to stomp you with the whole you're a storage company. Why are you at AI Field Day? But alas, we'll get tough questions the next time. Tougher questions for you the next time you appear. I'm going to not open it up to the delegates to ask any more questions because you guys will throw me off and not make it that I don't end up on time. If you want to find out more about Vast Data, links below, etc. If you want to find out more about the Futurum Group and the CTO Advisor, the web, thefuturumgroup.com, all of it will eventually be there. Thanks